Hi, welcome to this Open Security Summit session, December 2022, and we continue with the threat modeling theme that actually is being seen in a number of different sessions today. And we talk about the survival guide to implementing threat modeling. And we got Miguel and David, and Dave, over to you guys.
Okay. Thank you, Denise.
Thank you.
So short introduction. My name is Dave Stein. I work for a company called Q Experts. We focus on quality and improvement and everything related to that. I have many different titles, and one of the things that I like is ivory tower basher, as in I like to do things differently. And I have a whole bunch of interests, which you can all see in this cat, which I also love. And my partner in crime today is Miguel.
Hello. So my name is Miguel Llamazares, and I'm the cyber consulting lead at One eSecurity. And well, in the past, I worked in the airline sector as a systems analyst. I also did some stuff at cybersecurity in researching and a little bit of pen testing. And well, a part of my technical side, I'm also fond of process stuff like design thinking, the threat modeling, or creating cybersecurity product roadmaps, for instance.
Oh. So, as Denise already said, this is another threat modeling talk. And well, Miguel, let's explain why do we need another threat modeling talk?
Yeah, that's the elephant in the room. Why yet another talk about threat modeling? Well, despite there are some good initiatives on how to implement it, plus dozens of methodologies, it's still a challenge nowadays to implement threat modeling from scratch. So methodologies and frameworks are a way too rigid or too open-ended or too ambiguous, and that decelerates the adoption of threat modeling. So we missed something and identified some disconnected points of improvement. And we decided to organize all these ideas. So why not let's threat model the threat modeling itself? So we applied the 4 questions of the manifesto against themselves. That is, what can go wrong in the did we do a good enough job phase, and what are we going to do about it, and then propose some mitigations to do so. And that's how everything started.
Okay.
Well, 4 evenings later, we ended up with this mess of a diagram. And despite we uncovered some interesting ideas, it grew exponentially, and it was hard to make it actionable. So things got too complex, and we needed to find a better perspective to organize all these ideas.
Yeah, so exactly. So we started to think about, okay, why is this so hard? And while doing these sessions with Miguel, I was also reading a lot about complexity and how to do software development. And it dawned to us that, hey, basically what we're trying to do is something in the field of software development. And software development is a complex system for those who know Cynefin. And for those who don't know Cynefin, being in a complex system means you cannot predict what works in your situation. So in the sense that what might have worked somewhere else doesn't necessarily work at your place. So in a complex domain, things like good practices and best practices are not necessarily the thing to go forward. There's only one way to navigate the complex domain, and that is to experiment and measure. Do something, see what the effect is, try to get some lessons learned, try to find the boundaries, and do it again. And all this is talked about beautifully by Dave Snowden. He's one of my heroes. And basically he says you cannot understand a complex adaptive system through modeling or analysis. You can only understand it by interacting with real-time feedback loops of multiple agents, so you don't get cognitive bias. And while looking back at the map that we were creating, we already saw that there are plenty of ways to do certain aspects of threat modeling, not only just Stride, not only just DFD, there's multiple, and we thought, okay, let's turn it around and let's give a bunch of alternatives on how you can do threat modeling. So that's basically why we said, okay, maybe we should do a talk about this. And this is not a new methodology. This is not the new framework how to implement threat modeling. This talk shows you which problems we've identified while doing threat modeling, and give you some ideas about, okay, what alternatives do exist? What experiments could you do to make things easier? So none of this is you should do this. All of the things that we're going to show you is maybe this is interesting for your organization to try out. Yeah, and the first thing, we try to categorize it a bit. The first thing that you need to do is get your first success story, or actually your first failure story. Because one of the problems that we identified is that implementing threat modeling from scratch is hard because people don't know what it is. People start often with big upfront investment in terms of training and hosting all sorts of workshops. People do not understand why they do it. Yeah, for the security guys, they don't want to do it because they already have a lot to do. So all these things you typically encounter when you start doing threat modeling. So we thought, okay, how can you approach that? Well, one of the things that you can do to fix this problem is to reduce the learning curve, make it easier to enter threat modeling. So pick your battle carefully. Don't start with things like a Stride and a diagram. You need to find some tangible at first that shows people why threat modeling is useful. And actually, there's already a lot out there that you can use. And many teams use personas to do thought experiments on the application that they're building to identify how customers are using their application. And you can easily create evil personas that people that also use your system, but not with the best intentions. And make it really tangible. What are those people looking for? How do they operate? What behavior do they express? That's a powerful technique. Another technique that you can use is HAZOP. HAZOP is a methodology also developed years ago. And basically, it is sort of keyword injection into user stories. And so many teams use user stories in the sense of I want to use I want to log into this application and view my details so that I can check my orders, stuff like that. If you inject words into those sentences, you get different kind of stories. And especially the word not is powerful. If you inject that at random places in that user story, you get a situation that describes something else. And then you can get the team to think about, okay, is this something we should worry about, or is this okay? So if you have the story as a user, I want to log in to view my details, and you get the story as a not user, I want to log in and view my details. Well, that sounds like somebody who should not have access to the system. Or as a user, I want to log in and view not my details. That means that you're seeing someone else's details. That would definitely be a wrong thing. And so by these HAZOP keywords injection, you get different stories that get you to think, is this something that we should worry about, that we want to prevent? And that's a very low entry into the idea behind threat modeling without having to explain any of the Stride technology, having to explain, create any data flow diagrams. The third technology that we've identified that's quite powerful is TRIS. TRIS basically starts with the idea, okay, how can we make the worst situation possible? And then identify, is there already stuff in there that we're actually doing? and then you identify the stuff that you should fix to make it better. So it's all about using what you already have, user stories, personas, description of the processes in your application. Try to make that more, make bad versions of that, and then let the team think about, okay, what would you do about that, without having all this investment in this pretty steep learning curve. So, Miguel, next part.
That's it. So, well, once you have that minimum viable threat model that they describe, in order to get traction, you ultimately need to get buy-in from the involved stakeholders. And why to do so? Well, at the end of the day, business cares about money, and threat modeling can be time-consuming. So it's also hard to prove the value of threat modeling, because as it's a proactive measure, you don't get immediate and objective feedback. And finally, people are selfish, and well, that's a clickbaity way to put it, but we should see the pros and the cons from each stakeholder's perspective. And threat modeling playbook did a pretty good job identifying these potential benefits from each stakeholder's perspective. So basically, there are three main options. People either don't have time, or they don't have the expertise, or they are just not interested. And in the following slide, we will see how to address those. That's it. So how do we get buy-in? Well, mainly by measuring and prioritizing. We cannot improve what we don't measure. That's the idea. So the first tip would be to don't be right, but be useful. So by definition, a measure is a reduction of uncertainty. So it's not an exact carbon copy of the reality. So we need to don't try to go for perfection in order to when designing the KPIs and stuff like that. We also have to have in mind the ROI when designing those metrics. That's the idea, because instead you should focus on usability, how this metric will be used in the future. What problem are we trying to solve? Let's start from there. Another tip, which is from our mate Mike Sass from SalesHacks, is to try to connect the vulnerabilities to tell a story. It's better to say we have blocked the top 5 attack vectors according to our threat landscape, that we have protected the 70% of the inputs against cross-site scripting. So always try to add that layer of context that helps you to fill the gap between the security team and the business side. Finally, well, next, try to translate the outputs to money, because that also helps to fill that gap between with the business side. And despite you start using qualitative methods, for the sake of simplicity, try to translate the outputs to money. Again, don't try to be exact. A high-level estimation are fine. Don't be right, be useful kind of thing. And well, also the prioritizing is key in this context. So I recommend you to spend some initial time classifying the assets by risk or impact. So this task will maximize the impact of the threat modeling practices. So start by the cron levels and evolve over time. That's the idea. And finally, some random tips to address the main stoppers there that you may encounter when trying to get buy-in, which are no time. Well, design specific KPIs plus use the top-bottom approach, and that is try to convince the decision makers first, those who can, for instance, allocate more time to threat modeling practices, or who can purchase trainings for teams. That's the point. And next, no expertise, leverage current practices, as David implied in the first section, and also try to train your team in threat modeling. And finally, not interested. That's the trickiest one. Try to identify the root of the cause, because if they don't have time or expertise, we have already covered that. And also try to leverage the security champions to help you evangelizing, and implement a reward system, perhaps to involve people or to collaborate. So let's move to the final slide. So, well, how can we address those issues specifically? Well, first off, what I call the ultimate threat modeling KPI is to measure the amount of vulnerabilities in each phase / environment. So once the threat modeling practice is evolving, presumably most of the vulnerabilities will be spotted in the design phase. So the numbers of the next phases will have decreased, as you can see in the chart below. So this is very visual and can be easily translated in vulnerability in production and in development. And that's the money saved with threat modeling, and how much requires the threat modeling process itself. Again, a high level overview is fine. And if you subtract both amounts, you get the net value of threat modeling plus the value brought by the risk reduction. So you can connect, this is connected with what I call the CTI loop, which is related to the fourth stage of FASTA, that is collecting internal and external threat intelligence to modulate the threat modeling practices to address those trends. So setting that collaborative channel with the defensive security team is crucial for success. You can also design another cool KPI, like the number of attacks neutralized thanks to the threat modeling initiatives. And that's very easy to sell. Next, below you can see the table, which is the weighted shortest job first, which is commonly used in Agile and can help to solve prioritization conflicts. We divide the cost of the delay by the duration of the task, and you rank the output. So it's not efficient to delay a task that will require more time to fix in production. That's the idea. And last but not least is the time to fix based priority. So, well, in addition to your risk or impact calculation, you need to consider also the time spent in the task itself. So if a high impact can be addressed or sorted out now, don't delay it. So we can use high-level categories like less than a day or less than 2 days or less than 4 days or more. And if those tasks are small, like the ASVS controls, for instance, you could try to pre-calculate them as possible to save some time. That's it.
Okay, so if you did that, so you now have teams that are doing something with threat modeling based on stories or personas or whatever, and you agreed on how to measure things and how to prioritize things, then it's time to expand your view. So this is the time where you would typically revert back to flow diagrams and stuff like that. And then you quickly run into the problems that creating flow diagrams is really, really hard. In a typical threat model session that is being done ad hoc, you spend 15, 20 minutes on putting something on a board. That is definitely not perfect, definitely not a reflection of the reality, but for time's sake, you start working with it. And quite often, that diagram is only used in that threat modeling session. So it becomes really hard to get a up-to-date version, because basically every time you're creating a new model, you see a lot of mixed context in those models, high-level stuff, low-level stuff. You see business processes, and then I don't know what transportation protocols with arrows in between. You also see that it's really hard to threat model large complex systems. For example, threat modeling a supply chain. That's quite of a nightmare if you want to do it in real detail. It typically doesn't look at the risks due to partnerships, SLAs, contracts, stuff like that. So you see that there's a lot of stuff in there. So we thought about, okay, how can we make that better? And actually, threat modelers are not the first persons in any organization to encounter these problems. Architects have these problems too. If you're the architect, the enterprise architect of a large organization, you also want an overview of everything that is happening in your organization, but you're not putting it in one single diagram. So architects created something they call the C4 model, which is basically a layered model. And the easiest way to explain that is to look at how maps are working. So if you want to know where countries are, you look at a very high level at the Earth. You see the island, you see where the borders are. That gives you a certain level of orientation information. That is enough to say, I want to go to that part of the world. It doesn't tell you which cities are in that region. If you want to have that level of information, you need to go for that specific region one level deeper. And the same is true if you want to see stuff at street level, or if you really want to have detailed information on a specific road. So the C4 level basically stacks these different fields on top of each other, and you can just move up and down the stack depending on where you want information for. And the C4 model does basically the same thing. And so there are 4 views. The highest level is process views, processes in your organization. Within a process, you have the technology stack. In the technology stacks, you have all the components, and in the components, then you get to the dirty technical details. And there are different threats on every level. So you can easily use the C4 model to do layered threat modeling over the whole organization without having all these mixed contexts, without losing information on the boundaries, without having to create data flow diagrams the size of a room. This model allows you to be able to move up and down the stack while still having the right level of information. Another way you can do is if you want to map your dependencies with the outside world, Worthy mapping can be quite powerful. And we have an example later in this presentation. But with Worthy mapping, you can basically combine the value of a specific component or part of your organization and say where it is in the evolution. And depending on where it is in the evolution, you can also fine-tune your risk strategy, your mitigation strategy, to make sure that you pick a solution to approach that can actually work. And there's a lot of work already done in this area. It's just not heavily used. There are also things that we have forgotten over the years. And I recently did a Lean Six Sigma training, which is really, really old stuff considered to most people. And one of the concepts in there was the house of quality. The house of quality gives you a complete mapping of all the components in a system linked to what your customer actually wants. It also gives the interdependencies between those components, the relative importance of each aspect. And yes, it takes some time to make that, but it's something that you can easily keep up to date. And it gives you a detailed level of insight on where should we focus on if we want to fix stuff, what is important and what is not. So this helps you with getting visibility in the complex system of an application or a system, or you can even do this on a business unit level. And at the same time, it helps you prioritize all sorts of stuff, what is important and what is not important. So there are already a lot of tools out there to help you combat the complexity of large systems, of supply chains, of systems with a lot of external dependencies. And our advice would be to just start using them. There's very likely already people in an organization having experience with these kind of tools, just not from a threat model perspective. So if you just add a flavor of threat modeling to it, you can be very successful and even have models that can be used for multiple purposes. And that again increases the adaptability of threat modeling. Okay.
So the next phase would be to become proactive. And why to become proactive? Why that's a need? Well, because prevention is not enough. So threat modeling mainly focuses on preventive controls, but that's just one layer of security. We should also consider detection and response measure as well. And also to becoming proactive is important to address the unknown unknowns, because it's impossible to predict all possible variety of attacks, and we need to take proactive measures to overcome disruption and design resilient systems. And finally, well, postmortems are late to the party. Well, by definition, of course, they are late to the party. But what I mean by that is that the fourth question of the threat modeling manifesto, which is, did we do a good enough job, is commonly addressed reactively. Like, what failed in production so we can improve next time. So also this question is addressed subjectively, like at the end of the session, do we think we did a good job, or what are your feelings about it? So we should find a better alternative to which is more objective and replicable in order to be efficient in that sense. So let's move to the next one. Okay, so how do we become proactive? So let's assume that all our controls suddenly fail. So can we detect the threat? If not, that's a blind spot, and we need to spend more time with those situations and to pay special attention, I would say. So we could even add the detection variable to the prioritization formula, like frameworks like FMEA does. So next, what's the response plan? Okay, we have implemented these prevention and detection controls, but what if the bad guys manage to evade them? So what's the plan? How should we escalate it? Who is involved throughout the process? This needs to be defined beforehand. So also don't be afraid of failure. So rather than securing an stupid idea, try to design systems with alternative workflows that reduces the impact of a failure. So two proactive questions that we should ask ourselves when designing a system is, can we fail safer, and also can we fail faster? And finally, there are factors like uncertainty, complexity, ambiguity. Those are surrounding not just the software systems itself, but their environmental and business context. So we need to take action and be proactive in order to adapt our strategies around those variables. Next one. So what can we do about it? Well, we could use residuality theory, and as a disclaimer, this is a huge topic, so this is going to be an oversimplification. Google Barry O'Reilly's work and check his talks on YouTube. But it's software design heuristics for complex system to design software systems that are resilient. So there are three main components that could help in the threat modeling context. The first one is contagion analysis that is related with the host of quality that Dave described in the previous section. And it is in terms of analyzing the dependencies between the components of the system. So some vulnerabilities can just be spotted when seen at the big picture, not at the individual components by themselves. Also, you can introduce stressors, and an stressor is anything that is unseen by the system, but it impacts the components in some way, and they must be random. And introducing the stressor, we can see how they affect the system components, which are the dangerous stressors and also the most vulnerable components. And finally, the most interesting point is that this could be empirically tested. We can have a training and testing set of stressors and see if the system hardened with the training set can survive the testing set. And well, also the peer reviews. This is very straightforward with no learning curve. I borrowed this idea from Adam Sostak. One quick tip in this regard is to provide a minimum necessary context to avoid the bias between the reviewers. And well, also in terms of the asset catalog in your CMDB, you could combine the CAA, the standard, the triad calculation with VUCA. And VUCA stands for volatility, uncertainty, complexity, and ambiguity. So the idea behind this is that if an asset is very complex, has an unpredictable behavior, you need to pay special attention to those weak links, because any problem could be maximized. And well, finally, the caution engineering is closely related to residuality theory, is to see how the stressors affect to a control group and an experimental group. And finally, Mitre detect, which is a framework that maps your visualization and detection capabilities against a set of TGPs. Those can be from the Red Canary top 10 or the top threat actor relevance for your landscape. And that's it.
Okay, so now we've gone full circle. So we addressed all the four stages of threat modeling as defined in the threat modeling festival. What are we talking about? And what can go wrong? What are we going to do about it? Did we do a good enough job? So we arrived back at stage one. What are we talking about? And one of the problems that we saw there is that threat modeling typically focuses on the technology stack. And of course, we're all engineers, so that is our sweet spot. But there's more in an organization in terms of threats. And there's also people, there's also processes. And those are typically not being addressed by traditional threat modeling. Sure, you can do that with Stride, but it takes some practice. There are easier ways. And especially if you talk about complex systems, it's all about the social technical interaction of people using processes and technology to get their things done. You also see that this makes it very hard to address things like ownership of systems or cross-team collaboration, because technology is often not mapped to a single team or to a single business unit for that matter. And so you need different angles to assess those risks. Luckily, there's also things out there that we can already use for that. Again, it's not being used actively for threat modeling, but you can use the ideas behind those frameworks for your benefits. For example, there are two frameworks currently quite popular that look at how teams can optimize the way of working, how you can map different business streams and enablement streams within your organization to make sure that teams cooperate most efficiently. You can use the same approach to identify threats. And I actually did an exercise with that in the blog. The link is down here, but basically what it boils down to is identify what are teams currently responsible for, what are the dependencies between those teams, and where could things go wrong in those dependencies? Where could things go wrong in information transfer and stuff like that? So it's not a technical risk, it's a risk that you're not doing the things that you think you're doing, or you're unable to do the things that you should be doing. So team topologies and unfix provide you good ideas on how to identify risk in that aspect. If you look at processes, well, we also have a bunch of tools that we can use that. Again, value stream mapping is a very old technology. Basically, it maps out all the steps in a certain process. It tries to identify the parts that are complex or take a lot of time or that have a high failure rate. You could easily add the concept of risk or stuff going wrong to a value stream map. And that's also basically a form of threat modeling. Nowadays, in the agile way of working, we do not use value stream mapping anymore. We use event storming. It's essentially the same thing. You just use different stickies and nice colors and things like that. But again, it's making a layout of what is going on in my company and what is the consequence of certain decision points. And if you want to do a proper risk analysis or proper threat modeling on these processes, we already have a bunch of experience with that. We have the STPA and the STAMP approach to identify what are the steps between these processes and what happens if you fail to deliver on your promise or to deliver on your expectation. We have the failure mode effect analysis that again comes from the lean. It was originally designed for manufacturing processes, but it has been adopted to for non-physical processes, and it provides very good frameworks how to identify what matters, what doesn't matter, what could possibly go wrong, what are we going to do about it. Again, the whole mindset of threat modeling, it's just named differently. And also TRIS can help you here. If you have a process, think about how can we make this a lot worse. And if you identify how to break a process, how to make it inefficient, you can easily identify the opposite effect. How can we make it more efficient? So this way, again, you can go back to the beginning of the presentation and repeat that whole process for your people part in your organization, the process part in your organization, and just start experimenting what works in my company. Just throw these experiments on your organization, see what sticks, and build on top of that. And the stuff that doesn't stick, stop doing that. So we come up with this a nice flow sheet, Miguel.
Yeah, yeah. The idea is that to summarize all this mess, well, you're likely already doing some sort of threat modeling because the risk managers or the AppSec team or the blue team, they're probably doing something about it, but perhaps it's disconnected or the processes are intuitive or not structured. So our tip or advice would be first to identify what's been done and leverage those already existing practices with modular methodologies aligned with your capabilities, rather than trying to apply a huge methodology that tries to cover all the phases from scratch. Try to find these modular pieces like Lego bricks, and then start small and and don't feel failure, and adopt what works and evolve over time. That's the idea.
Yeah. And the fun thing is, while we were building this summary sheet to show you, okay, start small, experiment, analyze what happens, and redo that, we realized that we weren't inventing anything new. This was also already developed in the 70s by Mr. Boyd. It's called the OODA loop. And basically, this is the way to navigate in complex systems. And the guys the people at Cognitive Edge actually produced a blog about this. How do you manage, how do you determine the right course of action in the different Cynefin domains? So in the complex domain, they actually say probe, sense, respond, basically meaning just do an educated guess. See what happens if you start doing that. If there's a positive outcome, try to reinforce that. If there's a negative outcome, stop that experiment and try something else. And basically that summarizes the whole presentation we've been given so far. If you want to successfully implement threat modeling in something complex as software development, don't focus on a single methodology. Don't try to go for the silver bullet that works every time, all the time. Don't focus on what worked somewhere else. Start with small experiments that are likely to give some success, so that builds already on top of existing knowledge, and see if you can make slow improvements. And just build on top of that until you get to a situation where you actually have something that, first of all, gives you those results that you are aiming for, and second of all, something that is actually supported by the rest of the organization. And this was our last slide. Well, actually, we have one more slide. If you're interested in everything that we've read, we will hand out the presentation with all the links that we referred to. But for now, this is the end of our talk. So there's now room for questions. Things you disagree with.
Nah, this was awesome, man. Like, oh, such a great combination of lots of really, really cool topics, man. I felt like you're doing like word bingo, man, and all the stuff I love.
I had the same feeling about building this slide deck, Dennis. So
yeah, no, this is pretty cool, right? So in terms of the scalability, like, you know, those C4 models and those things. So one of the things that Petra was showing earlier today in the session in the morning was basically using a bit of code in Jupyter notebooks and basically using artifacts that you go into the particular component so that you actually start to put them together, right? And I remember with Petra, we actually did some experiments of using the C4 and other ways to glue things together, right? Can you expand a bit more on like almost threat modeling as code and how you actually start to really identify, for example, things like this and other workflows you guys done that were quite successful?
yeah, well, that's I mean, if you talk about threat modeling as code, then you're really at the lowest level. Eh? You implement your threats in the code as comments or as parsable statements. That would be the lowest level. The question is that the right approach if you want to threat model high-level risks between the systems in your company? So, for example, the web shop, the payment system, the ordering system. You're talking about different levels of threat, and I highly doubt if you can use threat modeling as code successfully at this level, unless you also do the whole C4 level as code, of course.
Well, that was the question I wanted to take you through, because I completely agree. And that what you said was a bit like, is the system, right? What was the phrase you used? The system is also the vulnerability, or there's a set of vulnerabilities that you only see when you see the overall system.
Picture.
Yeah, the big picture. But we can apply the same principles there, right? The only thing is that the components are now, it's almost like what altitude you are operating on, right? Because you know, you can do the same kind of mappings and the same, you know, threat modeling as code, you know, but you're almost working with higher order systems. but it's still able to scale. The concepts will still be the same, right? Make sure you capture in a sort of a language that you can version control it, that you can apply all those principles.
Yeah, and now that I think about it, I mean, you can do C4 model completely as code. You can define this piece of this component is at a certain level. If you tag the threads with the same level, then it should be fine. Then you get an overview. Okay, I'm at this architectural level, so I see this list of threads. If I go down one level, new threads appear that are only relevant within that context. That could technically work. Somebody just has to build it.
Well, is that idea is like the map, right? You know, every node in a worldly map should be a worldly map itself, right? So basically, where you start to, and then you be able to zoom in and zoom out, and then you actually have context, right? Sorry.
Yeah, that's pretty interesting because it's aligned with you have connected the threat modeling as code with the C4 model, and that's one of the challenges that I've identified, or one of my complaints regarding threat modeling as code is that you have a constraint to a low level of detail. So if you have dozens of components, as far as I know, it's not easy to abstract some of them, or to, well, if you are doing a diagram by yourself, you can abstract certain stuff in order to economize time or stuff like that. But you need to invest more initial time in order to create that baseline, and usually it's at a lower level. But yeah, that's pretty interesting. I don't know if there is a framework that allows you to combine different layers of detail in terms of threat modeling as code. That would be great indeed.
So I'm exploring using, you know, a graph for this and using Jira for this, where I'm trying to use the nodes and create nodes within Jira that allow me to connect the dots, right? And this could be done within the graph database, right? I just like Jira as a graph database because the nodes are very rich. But I'm trying to figure out a way to have that level of abstractness, right? Where you can go deep, but you can go also quite high. And also when you kind of, I guess my role now, because it's, you know, application is just one element, I try to apply the same principles everywhere. So if you look at all the way from erasures to devices, to SaaS services, to identity access management, to cloud stuff, right? All of those things, right, ultimately becomes nodes and edges in this sort of big kind of threat model or threat model that you want to create.
Yeah. No, but even if you do not want to make it that fancy at first, I mean, even in Draw.io, you can just create shapes that link to another tab in Draw.io. So you can start small by just deciding a high-level overview of your system. For each and every component, you create a new tab, and you can just put the threads as text in there. And then over time, you can just enrich the model. And the biggest advantage is you have something that doesn't mix contexts, or it allows you to at least separate contexts, and that remains valuable over time. And it's not only used for threat modeling. So you can even use that in other discussions with your team, with the architects, with, I don't know, decisions whether or not to go to a certain cloud. I mean, you get something that has more value than just for the threat modeling guys from the security department. And I think that is where we should aim for.
Well, that was ironically my next question. My next question was, what experience do you have in this adoption of these principles outside of the security team, where the dev teams, the DevOps teams, even the business teams, even like the risk teams, have they start to embrace this, your methodology and your workflows?
Actually, by accident, I have been a product owner for the last 9 months. So I'm actually at the other side of the fence. And if somebody asks me to do something for them and it's just for them, my default answer is no.
Exactly.
And so if somebody comes to me, okay, we are a bunch of stakeholders and we would like to get more insights in that, and you would help all 3 of us, then I'm more inclined to go along with that. Because
Yeah.
if I can spend an hour and satisfy 3 stakeholders, that's more valuable to me than spend an hour and satisfy 1 stakeholder. So from that perspective, anything that you can do by aligning with non-security people in your organization and ask a team to do something for you, by definition has a higher chance on success. But again, that's an experiment. That depends on the stakeholders in your organization. That depends on their involvement. It also depends on how long your backlog is, how experienced your team actually is. So there's not an easy answer to that. But it all depends, and that is what the message is in our presentation. There is no approach that will work by definition on beforehand, because it's a complex adaptive system. It will always work differently.
And the thing is that how everything started is identifying those stoppers, because when I tried to implement threat modeling in one client, suddenly they said, okay, what do you need? A diagram. We don't do diagrams. And okay, now what? I need an alternative plan, because if I want to impose the creating a diagram, that could be a stopper or stuff like that. So this is it comes from the experience of and the frustration of implementing rigid methodologies that they might have sense, but you don't. You also need to consider the context. So a modular approach by selecting different frameworks, smaller frameworks, you can combine them in order to better build your ideal threat modeling practice. That's the idea.
All right, and any final questions? Another amazing session on threat modeling. Amazing to see the evolution. Lots of great innovation on threat modeling these days. Really cool. All right, I don't think any more questions. Any final thoughts from you guys?
Just do it.
There you go. Just do it and share, and let's learn and collaborate.
Brilliant. Yeah, we are looking forward to hear your feedback. Just drop us a line via LinkedIn or whatever. We are happy to.
And please share these slides. They're pretty amazing. Let's publish the slides on OSS and then take it from there.
We'll do.
Great.
Brilliant. All right. Thank you.
Okay.
Thank you, guys.